So here we have another logarithmic equation and we want to solve for the unknown x. Now, the bases are the same, so let us proceed with grouping what's inside together. If we're adding, that means we're going to multiply what's inside. So we're going to get x in the first bracket multiplied by what's in the second bracket, which is 2 minus 2x. In our log bracket, this is equal to -1. Okay, so if this is what we end up with, then a couple things you can do, but what I'm going to do is I'm just going to grab this log base of 2 to the other side and make this turn into a base, because this was a log base to begin with. And if that happens, I've moved my log. That means that all I've left on the left side is going to be x 2 minus 2x, and the log base of 2 turns into base of 2, and this -1 right over here gets brought up and turns into the index of base 2. Okay, so what we have over here now, you can actually recognize that this is just a quadratic. So the right side is actually just half, because remember that if you ever have, so just as a side note, refreshing your log laws over here, that if you have a to the power of -1, well, more general case, a to the power of -m, this is really just 1 on a to the power of m. I'm just bringing my 2 to the bottom. Okay, and the left side, I'm just going to expand. So we have 2x minus 2x squared. Okay, now if you want to solve this over here, we don't like working with fractions, especially when you're dealing with quadratic. So I'm going to multiply it through by 4, or 2, just to get rid of that denominator. Okay, now this is going to become 4x minus 4x squared equal to 1. And bring everything to one side for quadratic. So I'm going to bring everything to the right just to make this term over here positive. I need this to be positive. Well, I won't say need, but it's preferable. So 4x squared minus 4x plus 1. Okay, and what can we do over here? Well, it's really up to you, but in this case over here, maybe is cross method okay? Yeah, let's use cross method for once. Okay, different color for this one. So factors of 4 over here. So you use 4 and 1 in this case, and we need to end up with -4 in the middle. Okay, so let's think over here. +1 here, that means 1 and 1 is a possibility, but we do need -4 over here, so maybe that's not good. And what about -1 and -1? If this happens, you get -4 and -1, so it doesn't look like this works at all. So I'm just going to cross this out. Okay. How about on the left side, we use 2 and 2. Choose 2 and 2. Then looks like this actually works with -1 and -1, because we end up with, so I'm just going to cross these out. To clarify, we're using 2 and 2 and -1, -1. So remember that this 2 over here is really just 2x and 2x, because both these multiplies gets you 4x squared. And checking this out, we're going to get 2x -2x as you go down. And as you go up, you also get -2x. This is equal to -4x. And it matches up with our middle term. Okay. Alright, so I was a little bit slow with the cross method there. No worries though. And looks like we have 2 linear factors which are the same. So really we have 2x minus 1 squared equal to 0. Okay. So we're just reading cross to cross over here. Yep, so that was our equation, and if this is the case, using null factor law, you know that x is simply equal to 1 on 2. Okay, let's just double check if half works. So let's go back up to our logarithm. So look at the criteria. The first bracket, x just has to be greater than 0, so this is okay. And this one over here, if 2 minus 2x has to be greater than 0, this is actually implying 2 must be greater than 2x, or x must be less than 1. Okay. And what we had over here was x equals to half. So it fulfills both x greater than 0 and x less than 1. So since both these are satisfied, this means that our solution here is valid.